Hello and welcome to um, Python V tutorials. My name is Emeta Victor, and today I'm going to be telling you or teaching you how to use blockchain to write smart contract. And this particular project you want to write is an authentication system. Just log in and registration system with blockchain. I'm going to write in a smart contract about that, and it's just simple coding knowledge and basic knowledge. So I'm going to be teaching you how to interact with the blockchain and write simple Solidity code that's going to interact with the blockchain. And the aim of this course is just to teach you and tell you that it is not difficult to write codes in blockchain. So I'm going to be running a user authentication and a user login system. We're going to be creating users and we're going to be logging in. So first thing first, you come to remix.ethereum.org. It's an online IDE, and you're going to create a new file under contract, and I called my auth So I'm going to remove the come here, and I'm going to add the license. The license is very important. This license enables you to be able to share your codes and stuff. The second thing I'm going to write is my version of Solidity I want to use to compile it. So I'm going to say pragma Solidity. I'm going to specify the version, and I'm going to just close it. So if I save it, I'm not supposed to have any compiling error. So for the compiling, you can see my own is set to 0.8. If I use any other compiler, I might have issues. If I use the wrong compiler, like maybe I use 0.8.14, I might have issues. So it's always best to use the right compiler. So as you can see, I'm getting an error. I'm going to use the right compiler here, which is 0.8.8. So I'm going to save this guy here, and it tells me that it is marked to check. So now the first thing I want to create is my contract. That's the name of the contract itself, and I'm going to be using contract, and the name of the contract is autumn system. So something like this. Now every of my code is going to live inside here. So the next thing I want to do now is to create an object that will look like my user's model, and to do that I'm going to use a struct. So a struct, and let me call it register. No, let me call it just users. So users like this, and because it's a struct, it's going to take values. So the first value I want to take is a string username like this, and a string no, let me use uint 256, and that's going to be a password, something like this. Now this is my struct, so this is going to be like the model of my users. Now the second thing I want to do, third thing I want to do, or second thing I want to do is to create a list where all my users will go to. And what kind of list do I want to create? I want to create a list that is going to take users with this kind of structures. So I'm going to put the type of list I want to take, which is users, and I'm going to put this square brackets. This means list. Then the name of, so I'm going to make it public so we can view it, and the name of my list I'm going to write all users like this. So this is all users, and it's empty for now. Now the first function I want to create is the registration, that is create account. So I'm going to say function, and I'm going to call it create account like this. Now it's going to take two things, surely the username and the password. So for the username I want to use string. It needs to be stored in the memory, and I'm going to call it username. While the second one is uint, as you can see, 256. It doesn't need to be stored in the memory because it's a number, so I'm going to put it as password like this. I'm going to make it public so that we can view it on the blockchain and it's easy to access. Then the next thing I'm going to do is I want to push whatever you give me from here. I want to push it inside the users here. So I'm going to say all users dot push, and now what I want to push, I want to push a struct that is users, and I'm going to create a struct which is going to take the username and the password. So let me save this if I'm going to have any error, and my code marks and check. Now this is the work of this function. Now the second function is to log in. I'm going to call it function login. Now the function login is going to take the same thing, so I'm going to copy it: string memory, users, int, and password, because I want to log in and I need those two info. You're going to give them to me and I'm going to check. And I'm going to make this one a public view, and it's going to return. So I want it to return something. I want it also to return a text, so I'm going to say string memory, something like this. So I'm going to have a warning, but I'm not. Now I want to check. I'm going to look through the public, the all users, to check for users there. Then I'm going to do some stuff. So I'm going to say for just for loop to check, and there are many ways to do this, but I want to look through the list of all the users, and I want to check if the user's name you give to me is the same with the one. So if you are from a coding background, you understand this. So for uint 256 I, so this is my the starting point. I is equals to 0. Now if I is less than, now to get the number of them, so I'm going to say all users dot length, just like JavaScript, all users dot length. Then I'm going to do the incrementation I plus plus. Then I'm going to come here, so it marks because I've not used I, that's when I'm getting a warning. So I'm going to say if. Now you cannot compare strings like that in you can't compare strings, because I want to compare the strings, the username and the one that is being looked through. So I cannot just compare, so I have to hash it first. So I'm going to use the way to hash it. I'm going to use kcac, like this, kcac 256. So I'm going to use kcac to hash it, and one of the ways to hash things now, turn it in a way that the computer can understand. So I made a mistake here. Kcac, yeah, 256 ABI dot encode. So it's not compulsory for you to cram this one, but you can just always impact. Then what do I want to hash? So what I want to hash is the username I get. So I'm going to say if all users, like this, then I'm going to put the I itself, so the index, the particular index dot the username. So I want to check the username first. So if the hashed one, because we've hashed this guy here like this up to this point, like this is up to this point, is equals to, we want to hash the second one. So I'm going to pick this guy here. I want to hash the second one, and the second one is the username I get from this side. I'm going to put this guy here. So if the index of the username coming from the index of dot from all users is equals to the one you typed in the function, what do I want to do is I'm returning a string. So I'm going to just check now. I'm going to first check again if the password is correct. So because it's password, I don't need to because it's uint 256, I do not need to I don't need to, how will I put it, encode or decode. So I'm going to just put all users I dot password is equals to password. So just people coming for coding background will understand exactly what I'm doing. So I'm checking if that username match the one you put. Then if it's matched, we just go ahead to do what? We'll go ahead to check the password. So if the password is correct, I want to just return logged in. Else, I want to return incorrect password. Correct password. Or let me just say user found, but incorrect password. So I'm going to put it like this. So I'm going to do this guy also, so I shouldn't have any error. So Now, after if this for loop runs and there is no password coming from, there is no user, you didn't find any user, you want to just return user not found. So I'm going to have to close this guy here, and that's for the code. We are done with that. So the first one is a struct of user. The second one for a list of user. This one is to create an account because we're actually pushing. So let's compile the code. It's already compiled, so it's compiled. So I'm going to come to this particular side and I'm going to just so I'll put it to you can use anyone, remix VM London. So this is just JavaScript environment. So I'm going to use this one. So I'm going to come to deploy. As you can see from under here, I have my auth system deploy contract. So let's check. So the first one is to create an account. The second one is to view all the users. So if I come to, you have to put an index. The first index, there is actually no user there. As you can see, there is no user there. So let's create an account first. So I'm going to put my name, which is Victor, just like this. I'm interacting with the blockchain. I'm going to put a password 56. I'm going to transact. Now if I come to all users and I click on all users, I get the first one. If I put 1, I will not get anything because there is no user. So if I come and I put David, I'll make this one 6 and I transact. I come to all users, I get David. If I put 0, I get Victor. I'll put for last guy, I'm going to put Dio. I'm going to put 1, 2, 3, 4. I'm going to click on transact. That's created it. So 0 is Victor, 1 is David, and 2 is Dio. So now I want to log in and check if this actually works. So I'm going to put the first name, which is Victor, and I'm going to put 1, 2, 3, 4, 5, 6. Sorry, not here. The username. I'm going to put 1, 2, 3, 4, 5, 6. I'm going to call it. It says user not found, but user found but incorrect password. So the user was found, but the password is incorrect. So I'm going to put this one. It says logged in. Then I'm going to try for David. I'm going to put 6 and I get logged in. If I remove it, I get user found but incorrect password. What if I put somebody that does not exist, Emeka, which I did not put? I'm going to call it user not found. And that's how to create a simple login and registration system in blockchain. Well, I'm going to see you in other videos, and do not forget to follow me on YouTube.